Okay, so as mentioned, when you switched from the lesson previously to this one, the difficulty level increased. The questions are harder, and you got to start thinking on your feet, so to speak, and actually doing some research and stuff like that, which is part of what this class is all about, is forcing you in some ways to kind of step out a little bit from what's easy and straightforward to what's more challenging. But at the most part, doing that gives you the feathers in the cap that you need for the bosses. And so when it gets tough like this, don't worry, don't panic, just realize that the hard is good because you're going to learn a lot from the hard. Now, opening up the floor to questions on this current assignment. What do you want to ask? Also, I will make a recommendation. Technology is great, but you're going to find your life a lot simpler and more stress-free if you'll just typically work off of a flash drive between all your devices. Transferring things back and forth and using different technology sometimes makes it harder than it needs to be. So a flash drive is the best way to probably hold on to the stuff that we can work on here, at home, wherever the case may be. Okay, so questions on the assignment you want to ask. Now is the time. Gotta give me something. Can't help you if you don't ask a question. Alright, I'll get the ball rolling. Is there one that you had a particular problem with or challenge with?
The whole time.
Can't say the whole thing because there's too many of them that are super easy. Like when it says, what is this line? That's a simple, easy one. But I can get specifics.
With number 7.
Number 7. All right.
The R3, when it's using the circle and then used on the R.
Okay. All right, let me... Okay, now number 7. Yes, this is a challenging one. For sure. So, all right. So it says, provided the top, front, and front view of a part, you will notice the dimension value of R3 is used in 2 separate locations, yet it describes 2 separate features of the part. Describe in your own words the differences between the 2 part features that R3 is used to describe. Okay, so orthographic projection taught you that when we're looking at this thing, we're looking at 2 views, all right? Now, first question is, what does an R on a set of drawings stand for? Radius. Now, what kind of things are radiuses? Circles? But we typically don't use a radius for a true circle.
Curve.
Half circle, curve. How about a filleted edge, rounding stuff off? So radiuses typically don't deal with raw holes. They deal with things on the drawing as you see, like this. This, for example, is not a complete circle, but it's sort of round, right? So it's got a radius. This one here, there's a radius here where it's going a half circle. By the way, let's look at this one for example. Get this thing to hold still. Why is this value right here given as a radius and not a diameter? This arc?
It's only half.
That's right, it's only half. So, going back to the question, now that we kind of understand what we're looking at, describe in your own words the difference between the 2 part features that the R3 is used to describe. So first of all, we find the R3. There's one. And let's see, where's our other one? Right here. So, first off, what would you visually say is the difference between the 2? One's a circle, one's an arc. One's the exterior, one's rounded off. Right? And let's see. Yeah. So, it doesn't necessarily have to be a complex response. It can be very simple and straightforward. It can be like, okay, this R3 is the center, or one R3 is the center of the hole to a feature that wraps around the cylinder. And this R3 is a long curving arc. Now, if I were to give you a choice, and we'll call this one this is the left R3, this is the right R3, which one would you say is more like a fillet? The left, right? It's a rounding off kind of thing. But we're not rounding this feature off, are we? This is a whole big arc going around the part. So what it's trying to get you to do is just kind of think visually. Now, obviously, when it says a fillet is R3, what does that really mean? When it says it's got a radius of R3, what does that mean? How would you fabricate that, you think?
You'd have like a 3, whatever the value, 3 degrees.
Well, that's the question. And think about it. How are you going to take a grinder, perhaps, and fabricate a radius 3 around something? It's very actually hard to do.
You'd have to mark it first.
Right, you'd have to mark it. So one of the things to understand is when you're rounding things off, especially in fabrication, when you're rounding something off, you're oftentimes, look how the circle is actually centered back out here. Not, this one's inside the part, and yeah, we could kind of figure that out, right? We could actually get to the center of a hole and maybe measure out and find that value all the way around, correct? But when it comes to this fillet right here, that's on the outside of the part. We would have to do some kind of jigger system to kind of make this happen. But the key thing is that you just understand, yes, you can have a radius 3, but that radius could be part of an arc, or it could be part of a fillet that's used to smooth things off. So we're just trying to get a feel, can you kind of distinguish that in your mind, that you're going to make this with maybe one tool system, or maybe this shape is a different tool system. But what's key thing is, fillets are typically radiused from the outside of the part, whereas arcs and those kind of things are radiused typically from the inside of the part and are made off of the part. But you might have to set up a jig outside the part to make this happen. Does that help? Okay. Give me another question. Fire them off. What we got?
And I don't know if I stated it correctly, but
That's okay. I don't get too picky about that.
to me it looked like they were saying this is an outer radius and this is an inner radius.
That would also qualify. Yeah, they are the same. Dimensionally, they are the same. But your fabrication, they are actually creating two different components to the same part. Give me another one. Remember, we make these things to be challenging. Not deal breakers in terms of the class by any means. They are challenging. But they are challenging just to get you to think. You'll miss some, you'll get some, it's okay. Number two.
Showing the line.
Yep.
Just a headline.
Yeah. But what would be a little bit better way? When we've called it out on drawing, what would we actually called it? What's the S word? Section line. But a cut line is, in theory, yeah. A cut line's good, but a section line is a little bit more appropriate. Because you are cutting them through. Give me another one. That is absolutely right. Third one is a break line. Now, how about this? Let's talk about question one. Describe in your own words why section views are an important part of blueprints. Give me some words, give me some reasons as a class why they're important. That's right. Now, do they usually work on the outside of the part or the inside of the part? They're all about the inside, right? They help us understand things we typically can't see. So that's a viable answer. Give me, all right, so let's look at this number 5 here. Rectangular block of wood is 4 by 2 by 1 thick with a drilled hole through it located in the block's center. So visualize that in your mind. Sketch an example of this part showing its dimensions and insert the image or sketch below. You can do this on paper, take a picture, insert it manually, blah, blah, blah. So in your mind, you see a block of wood, 4 by 2 by 1 thick, it's got a hole in it. And how would you draw that out? So you could actually, first of all, you could use word paint, right? You could draw it out on paper, right? And would you agree that's maybe 4 by 2? Yeah, that works, right? It's got a hole in it, correct? Now, the question says, dimensions and insert the image below. So, okay. So, if I wanted to be real technical, I could do this. And let's just say I didn't require it, but what if I wanted to set it up as orthographic projection? What would I need to add to these two drawings? Well, that's true, but what else am I missing? Like, line type wise. Got some hidden lines. Right. Now, I didn't say you had to do it, but while we're at it, we'll just do it this way. Now, what did I actually absolutely require you do? Dimensions. So, what kind of information would this thing need? Do I need to identify what the hole is? Dimension-wise? Sure. What is the diameter of that hole? Didn't even say. So, you can put whatever you want to. Guess. You can just leave it blank in all honesty because I didn't specify, but it's got a hole drilled through it. But that would be a crucial dimension, right? What would also be a crucial dimension? The length of it, correct? Sure. How about the width? Right? How about the thickness? Right? But I need a little bit more information. Location. That's one of the key things we want to make sure you're getting out of this. So it goes through the center, so it's going to be 2 that way, and it's going to be, you know, a 1 this way.
Hey, for this one, I drew an isometric view. Did you take that, or does it need to be graphic?
As long as it's got the dimensions to convey that you understand you need length, width, height, location dimensions, yes. Orthographic is a little bit easier for folks to understand, but we can deal with isometric. It's fine. But in all honesty, when you look at this, this is what a true print's going to look like. This is, or a sketch of a print. The key thing, we just want to make sure that you have you take the time to think through how many dimensions do you need? What's too many dimensions? That kind of thing. That's what we're going for with a part like this. Very open-ended. Now, can I take this image and insert it right into Word? Absolutely. Word Paint has that ability to select, copy, and paste it right in. I could do a screen capture, but essentially I'm done at this point. If you did it on hand, no problem. Take a picture of it, insert it. That's the way we're going for communication. Give me another one. Give me your most challenging one of the bunch. If you haven't gone that far, skim through and give me the most challenging one of the bunch.
Actually, on that number,
Yeah.
2.
Okay, 2?
No, 3.
3, okay.
I'm sure I just didn't remember it
Yep.
seeing in the video, but for some reason I just thought that might be like a type of dimension line, but it's actually a break.
It's actually a breakdown. Did somebody ask a question? Here, go ahead. What'd you say? 9. All right. Let's talk about 9. Okay. So we're talking about the same drawing, previous question, which is the only drawing above it. We do that a lot. We refer back to the same drawings. At the top view, there is a diameter value of 5. But it does not look like a normal leader for the showing of the diameter cylinder or hole. In fact, it looks like a typical linear dimension design, or linear size dimension. Explain in your own words how a technician looking at the top view would understand that the 5 relates to a cylindrical shape. So, we take a look here at this view. All right? Now, normally, when we have seen circles drawn, we have seen features show up with that symbol right there, which of course we identify as a what on a set of plans? What does that symbol mean? Circle with a slash through. What's that mean? Diameter, right? Okay. Now we're used to seeing that. We're also used to seeing holes on a set of plans look like this. So like there might be a diameter symbol for this, diameter symbol for this. Let's say this is 1, this is 2.5 or something. We're used to that, agreed? That makes sense to us. Now, you'll also notice that most holes just have this nice little leader that goes to it and points to it, right? In this particular drawing, however, they do something totally different. They go from here to here. I'll zoom in just a wee bit more. They go from here to here with a linear measurement that you're normally used to seeing as size or location. But then they do something to help you understand it's talking about a circular feature. What do? They just add the diameter symbol to it. You will see this done on plans a lot of times when they're trying to deal with cylinders from a different view and the drawings are just starting to get crowded. That they'll actually use a linear type of dimension, but they may add in a diameter symbol. Not only that, but there's another trick to do. Sometimes they'll do this. Let's say you're looking at a plan, and it's got a feature, and you see this symbol. What's that tell you? And the unit's just 4 for sure, but what's the symbol look to you as? A square. Now, when you're dealing with parts that actually may have like a square notch or a square feature, they'll just throw a square in front of it. They can, if it's round, they'll throw a diameter feature in front of it, but they'll still give it to you on a linear way of dimensioning, okay? So all you have to do in the scenario like this is just realize that, yes, that looks like a normal length or width measurement, but they throw the symbol in there to make sure I understand that it is a cylindrical feature. Does that make sense? So for an answer like that is, you just say, hey, it's got a diameter symbol in it. Tells me it's a cylinder. That's how I'm going to know. Give me another one. Actually, first, does that make sense? It's all about the symbology in blueprints. It really is. Next one.
Okay, say you had a rectangle.
Okay.
You're doing the location lines.
Okay.
You had a circle over here.
You got a
circle
rectangle.
over here.
Okay.
Would you locate your lines from the same side and go over?
Ah, good question. Okay, so let's say I've got a part that looks like this. What's the best way, and we talked about this just for a little bit, what's the best way to dimension if we're dealing with parts where precision is concerned? We don't want people to have errors. Do we dimension like this? Or do we dimension like this? Top or bottom? So bottom gives us the less error potential. Not to say that someone's automatically going to make an error, but less error potential. So that way if they're off on this one, it doesn't throw this one off. So in terms of precision, what is the most optimum? If I had a situation like this, the best way to dimension something is to pick a couple of datums or pick a couple of surfaces that are pretty, static, pretty solid, pretty, uniform or a big part of the component. So for example, this surface is a good choice to dimension off of. So I go from there to there, and I'll keep going all the way over to here, and I'll go to here, and then I'll turn around and pick a surface that works out well for dimensioning. So I'll go this way, and I'll use the same surface. I'll go on a different side, but it's still the same surface. And I'll go this way, and I'll come over here and show the depth of the part, and there we go. So that dimension scheme, although you could rearrange it a bunch of different ways, is probably the best to avoid errors. Do you see why? We're using only two surfaces to measure off of. We're using this one and this one. And if I make a mistake on this one, it doesn't have any impact on anything else. If I make a mistake on this one, doesn't have an impact on anything else. Even if I make a mistake on the overall length, it still means that everything up to that point was correct. So this is a good format. Doesn't mean you have to do it exactly like this, but that would be a good way to do it. Another question. Let's get the gears turning this morning. What we got?
Can you put the other one back there?
Yeah, I can put the other. No, this one?
Yeah, no,
Number 9?
when you were just drawing that, put the one on top there that's not the best one.
Oh, yes. Not the best way. Anytime that you work off of something else that can be moved or something else that can be wrong. For example, this way is fine until you do this. See the difference? If I make a slight mistake on this measurement, what happens to this one?
So you're saying get the shortest one?
No, not short. It's the fact that if you take your tape and you measure from here and you drill a hole and you put a circle there, okay? Then you take your tape and you try to measure over to the next one. Are you going to be that good to get that measurement right? Well, let me say it this way. Are you going to have more of a chance of making a mistake?
Oh, I see what you're saying. You're measuring from that hole instead of going back over all the way and then coming back over.
Exactly. You're measuring from something that is static throughout the whole part instead of trying to measure off something that you just created.
Yeah.
That's what throws everything off.
Kind of like using a base to start with.
Right. And that's why we use the term datum, and that's going to come up a lot, especially in one of the big ticket items in geometric stuff. It's very challenging, but it's what employers want to see you have the ability to do. Yep.
Okay, this will have to do with number 6, the redundant
Okay.
dimension.
Yep.
I guess that, John, the one you just hit the hood,
All right. No, well, no, it's describing your own words.
like it's the 2 holes, so it basically it's just like repeating dimension.
Right. So, like in number 6, it's just saying, hey, describing your own words what redundant dimensioning is on a set of plans. Now, it's kind of mentioned in the lecture material what redundancy is. When in doubt, you could always just look up the word redundant and it'll probably give you a feel for it. But for an example, look at this. I give you a part. It has a hole in it. I show you the dimension here to here. I show you the dimension from here to here. And then I turn around and I show you dimension from here to here. Am I redundant or not? I am. Why am I redundant?
It doesn't even know what the dimension is, right?
Do what?
One of those dimensions isn't like necessarily, you don't necessarily need to know it.
Exactly. You don't. If you know this one, you can put the hole there. If you know this one, you can make the part. If you know this one and this one come from this way, you can make the part. So yeah, we don't really need an extra one here. And the reason we don't want to do that is because when you have on drawings, if someone gives you a drawing that has the same dimension repeated 2 or 3 different views, 2 or 3 different times, it actually increases the chances of mistakes. Also, it increases the chance of mistakes on the designer's part because if they make one change and all the other ones that are redundant don't match up, you get more problems. So redundant dimensioning is all about not giving more information than you need, not showing essentially the same value more times than is necessary, which is typically just 1. Does it make sense? All right, give me another one. That's why I like these assignments. These are the best ways to get through it. Do what?
It has nothing to do with, you have 4 circles that are the same size. Like 4.
Well, you've actually got a good point there too. That's another way to look at it. Let's say you've got a part that has this dimension, this hole, and they're all the same size. And you go through and you say, okay, diameter 1, diameter 1, diameter 1, diameter 1. Would you all agree that's unnecessary?
Can you just put like diameter 1 times
Yeah.
3?
Absolutely. And in this, what they'll actually do is they will say 4, or they'll actually do it this way. They'll put it in front of it. Key thing right there is that you realize, yeah, there's a better way to do this. So what they'll do is they'll say 4 by diameter 1 because there are 4 cases of this diameter. But exactly right. See how much cleaner that looks? That's why we do it. So if I went through in diameter, everyone, that could also be considered a form of redundant dimensioning when we don't need it. When typically the redundant dimensioning is usually more associated with measurements like locations and stuff like that, but this applies just the same way too. That would be redundancy, and that just looks better. You make less mistakes this way. It's just a better way to do it. Yep, go ahead.
The only thing I would want to, if I was looking at that, I would want to know is I want to make sure those are the 4 holes.
Well, if they're not, someone on the blueprint side is if those weren't the 4 holes, then like if there were other holes built in, if anything that's like obviously smaller, they're not going to worry about. But if there was a hole that looked kind of similar, they would turn around and point out that this is not the same one. It would be identified, and because the designer is ultimately doing this for good fabrication. So they're going to make a point if things are too similar to just make a distinction between them. So you don't have to worry about that. Other questions on this?
Number 11.
Number 11. Here we go. Referring to the same drawing as previous question, find the feature tagged as A. In the front view, you cannot tell if this is a hole or a cylinder coming out of the page at you. In your own words, identify which it is and describe how you can determine this from the drawing. So, in the front view, we have tag A. So, how can I tell this is a hole or if this is a cylinder coming out of the page at me? It could be both, right? So, what do we do in reference that? If you're looking at a set of plans and you have these two drawings in front of you, how are you going to tell me, and without a doubt, that this part, in fact, for feature A, is a hole and not a cylinder popping out?
Different section.
We don't have a section view. Well, the section view that's provided is not related to this component. Keep going with that thought process, though. You're looking at this blueprint right here in front of you. How are you going to be able to tell me? And I'm not saying you can't look at the top view. Look at the top view.
Okay, see, I thought we were supposed to.
My apologies. That's a little bit. Yeah, your objective is to just acknowledge that, hey, I can look at the top view and tell. Because of how can I look at the top view and tell, though?
Just got a center line in it.
We got center line tells you it's round, but what? Hidden lines, right. Your hidden line's going into the part. Now, let me ask you this. What if it was a cylinder popping out? What would I see in the top view that would be different? I would probably see something sticking out here, wouldn't I? Beyond the surface. Because if this line represents one cylinder, this 5-0 here, and this were to represent something popping out, I should see something popping out right here. Would y'all agree with that?
So doesn't it come out?
Doesn't.
The shape comes out from the.
No, the bigger cylinder does. Look at what A is pointing to.
So is it two different pictures or is it just one picture?
Well, this is the top view and the front view.
That's what I'm saying.
Yeah. So you're using them both. This is a blueprint. This is a part drawing.
Well, I got that.
Yeah. So you're looking at the two different views of the part, just the same way we did the orthographic stuff. And you can tell, okay, and you ask yourself, okay, which one is feature A? Well, that is this circle. Agreed? Everybody cool with that? That's A. Your objective is to find the things in the top view that relate to A. So, for example, is this edge related to A? Is this edge A? No. Is this edge A?
Yeah.
Yes. Does it go into the part, or is it, let me say, is it an extrusion or is it a hole?
Goes all the way.
No, I mean, like in terminology, is it like something that is extruded out of the part, or is it a hole drilled into the part? It's a hole, right? So it doesn't come out because it's actually, A is not actually material, right? It's a hole. So it's not an extrusion for terminology's sake. So nothing about A comes out of the part. Somebody takes a big drill bit and drills a hole into the part. But if I didn't have the top view, could you tell me that's a hole? You couldn't. So maybe I clarified that in my question where maybe I should have said look at the top. I didn't want to give it away too easy what I was going for, but you can use both views as part of your answer. So the response is you can tell A is a hole because of why?
The hidden lines going through
The hidden line's going through the top view.
Yeah.
A circular feature, it could be circular whether it's a cylinder or not, but that could be a solid cylinder or a hole. Both are circular. So that doesn't help in this case. What helps is top view. Hidden lines in the top view. Absolutely.
So that would, what would the top view be called?
Just top view. Yep, just top view. So the only thing is actually a section view is stuff like this that you see right here. Whenever you see hatching, that's a section view. Whenever you see letters like labeled, that's a section view. Okay? Give me another one. Throw another one at me. Give me some challenges here. Because, yeah, totally agree. I probably should word that one just a slightly bit better, but I said I didn't want to give away the answer too. Throw another one at me. All right, here we go. I'll give you one. Check out 13 with me. It says, referring to the same drawing in the section view provided as BB, would you say this is relatively the correct section view? So here we go. Let's take a look. This comes straight from kind of like the exercises you've been doing. So first of all, question, what view do I need to look at to top or front to reference BB, where it comes from? It's in the top view, right? How can you tell?
In the drawing?
Well, I mean, what symbol do I see in the top view? Right, I've got a section line labeled BB in the top view. So first of all, I know that I'm going to get my bearings from the top view, right? So the section view from BB cuts through this part. So now the next question is this, and this is the tough part of it. Here's the section view BB. Would you agree? This is what this is supposed to represent right over here, right? So my question is that the correct section view or not? What do you think? Okay, well, let's look at some of the rules of section views. If I take this part and I cut straight down through it, I cut through this component. Let me zoom in real quick right here. This will help. I cut through right here, right? That's solid part. I'm looking in that direction, right? Agreed? That's where the section views tell me I'm looking. So am I going to see more than just the cut section? Right. Got this little nub sticking out, right? So in our mind already, we know that we're going to be looking at some hatching and some blank space, right? We're going to see a surface that's not hatched. We're going to see a surface that's hatched. All right, so let's go over our section view. Do we see a surface that's hatched and a surface that's not hatched? All right. So far, would you agree that we're on the right path, that this is getting good? Okay, good. Now, the next question is, and this is the other tricky part, is when a section view is cut, you often rotate based on the axis. So you cut through and then you flip. So even though this may not be perfectly aligned to where it's supposed to be, we can see that it's relatively correct. So BB is a relatively correct version of the section view. Now, let me give you a counterpoint. What if I had drawn BB like this? Yeah, let's see, I did it like this. Would you say that that would be a correct interpretation or something slightly off? It would be wrong because I flipped it the wrong way. What if I flipped it the right way, but I did this?
That's wrong.
Now, why is that one wrong?
There's no space.
Right, there's not that extra component sticking at the side that I would see. All right. So a question like this is just to kind of is for you to kind of think through and say, all right, this is what it may look like. These are challenging problems, but it's what challenges us that gets us thinking, and that's what we're all about with this kind of stuff. Visualization takes a lot of thought with it. Give me another one. Fire away, come on. Something that you struggle with. Okay. So, referring to the same drawing, feature B. Does this hole go all the way through the part or does it stop partially through? Defend your answer. Now, another thing about my assignments, I love to ask you to defend your answer. Because there are some cases you can be totally wrong, but your argument is good, and maybe I hadn't thought of it a certain way, then I'll give you credit. Okay? Now, at the same point, if you actually just answer yes and you don't defend stuff, I'll take off. Okay, so keep that in mind. If it says defend your answer, you need to give a reason why. Okay? So don't give me yes or no answers when it says defend your answer because we're just going to count it off anyway. Because it's not following directions, which is all about what we're about is following directions. So, number 12. Does feature B, does it go all the way through or not? So let's take a look. We're going to take a look at the two views we have at our disposal, top view and front view. So, my question to you is, what do you think? Does B, this feature right here, this hole, go all the way through or not? And you say yes. Okay, so explain to me how you know that B goes all the way through.
Because in the front view, the hidden lines go all the way through.
Yeah. Your front view, we take a look right here. We zoom in closely. We see that, for sure, this hole, which lines up with these hidden lines right here, starts here at this surface, goes all the way through to this surface, and continues all the way through. So it absolutely goes all through. Now, what if I had drawn it this way, though? Wait, that's not right. Yes or no?
No.
It's correct. How can I tell? Then, of course, this is the front view again. How can I tell this didn't go all the way through? The lines stop. Now, they may not always give you this nice little triangular point. They may stop just by doing this on a set of plans. But either case, those hidden lines tell the story. The fact that you see this edge right here coming across and these lines not going down tells you it didn't go all the way through. So, next question with this then. Why does my center line go all the way through the part, even though my hole stops?
Reference to center.
Now, think about it a little bit more. What do center lines describe? Right. Your part overall is a cylindrical part. See? It's almost a full arc right here. So regardless if the hole goes all the way through, your center line would have extended all the way through. So because it's describing that cylinder. Now technically it's almost a half cylinder, so someone may argue and say, well, you may not have to have one there, but in theory it probably should. Okay? Now, another question. Does that answer that one pretty well for you? Make sense? Give me another one. Now another thing, in terms of collaboration, I typically do not have problem with collaboration. But, I say that with a little bit of reservation. Collaboration is one thing, but actually just copying answers and exchanging them, totally not going to work. But if a person's needing help and you're like giving them some ideas and they figure it out and they can describe it for themselves, different story. So there's a little bit of a gray acceptance area there you can actually do, but it better be in your own interpretation, whatever your answer is. All right, give me another. You want to hit this one somehow? Nice big drawing here.
I was on the one, I forget which number question, but they were saying what you may could do to better reference that the setback space there. And
Read through and figure out which one it is. We'll come back to it. Give me another one while we're waiting. Number 17.
Actually show the thickness.
Okay. Provided above is the front and side view of a part, and in your opinion, are there any dimensions necessary to make that the part? I need to put a "the" in there. To make the part that are not provided. Okay. Are there any dimensions necessary? Essentially saying, is something missing? So, your answer was, what'd you say?
Either the thickness wasn't provided, was it?
Absolutely.
Saw actual thickness.
You are absolutely correct. Look around the part. They give you all kinds of information. They show you, hey, this thing is this wide, there's the hose, here's this feature that's milled out of it. They even give you this right side view that's got the depth of that feature. But what do they never show in the drawing? The distance from here to here. So absolutely right. That's one thing that is missing from that one. And that will happen to you on the job. You will run into dimensions that are left off. And that's why people need to spend, especially people who are bidding projects, you really have to have all that information to start off with. If you don't, you can lose a lot of money. You know, you have to take your time to review plans and people give them to you for contract work or any kind of thing. You need to study them and look for things that go wrong. A buddy of mine actually works with a very large civil construction company, do a lot of highways. And he said when they get these big government contracts, first thing they do is they send their engineers and team and their construction guys through it line by line, page by page, looking for mistakes. Now, guess what they do? Now, they're a bidding company. So guess what they do when they find mistakes? Do you think they report them or do they keep it under their hat? Why wouldn't you want to tell somebody if you're a bidding company? You make more money on change orders. That's exactly right. If you see the mistakes and like you're in the especially if it's government operation who actually submits the drawings, they actually get to do change orders later on. So they'll bid the work straight up, and then they'll be like, once they start the work, they'll be like, oh, wait a minute, you all made a mistake. We're going to have to do a change order on this. And that's totally legal. Yes, I think it is. There might be a law against that, I don't know. But anyway, that's what they do. So finding those mistakes early on a set of plans, big deal, very beneficial. All right, now the next one. There might be some ethics associated with that. Would probably need to be addressed, but that's okay for right now. Let's hit this one. Number 19, referring to the same drawing as the previous question. Of course, this is the big one in front of us. What kind of view of the part is noted as B? What kind of view is this? That's right, isometric. Very common to be in the top right-hand side of the page or the sheet where it's kind of out of the way but gives you a sense of the drawing. So, isometric view. That was a give me. Give me another one. By golly, you better get 24. I don't know if anybody's read through 24, but you better get 24. Do it? Yeah. See, I make my answer sheets when I do these things, and sometimes I forget to delete stuff out. But in reality, number 24, let's just look at it. Yes, it does tell you the answer, what it is right there.
I thought you were asking us, is that why? Because it wasn't.
No, that's my answer. That's all the. You see, if that gives you a hint in terms of the way that I grade this stuff, it's not that your answers have to be perfect or well written. It's just like common sense stuff, okay, to work with. So make sure you do 24. And when I read your responses, I'm just wanting the truth, the honest facts. If it is a simple statement like because it doesn't need to be there, that's a true response. Now, of this, what can we ascertain in terms of what kind of part this is? What can we tell about this design? It's a pipe. How can you tell? Right. You've got basically somebody showing you a quick drawing. You can see there's the outline of a wall here. That's how you can tell. First of all, is it cylindrical or square? How can you tell that? Because you got the center line. Then you've got this outline, this broken out section essentially that shows you've got hatching here. So it's open, it's a pipe, it's long, 196 units, whatever they may be. And there's no real reason to show a different view, right? If I showed the top view, if this is the front view and I showed you the top view, what would it look like? Exact same. So that's why. All right, another question. Yep.
It was 21 that I was thinking.
Okay. A good challenge. Okay. Referring to the same drawing as previous question, again, that's the one above, you will note the dimension on the right side view of point 375, which is linked to a hidden line. Although this is not the best way to dimension a drawing, it does get the job done. However, in your own words, describe an alternative way the designer could have provided this information. Now, in your own words could also mean you take a screen capture and sketch it if you want to, that's fine. But you'll see that the designer used this right side view, and yes, it's not really a good idea for designers to give drawings where things like hidden lines are dimensioned. That's not good practice. It does happen, but it's not good practice. So, give me a suggestion that you would have made to show this information a better way.
I thought maybe a section view.
Right. And that's actually why section views are used for this kind of thing, because since we're not really supposed to dimension to hidden lines, could simply taken the section view AA and just thrown that dimension right over here, and that'd been totally cool. Okay? But absolutely. Could you have done another way though? Got another idea? Another way that sometimes folks will do it is they'll just add a note that just says something depth, or they'll give a depth arrow, which is a depth arrow, by the way, is just this right here. and they'll give a value. So, but a section view is a little bit nicer way to do it. So it could have been done either way. Those are probably the two most common ways they would have addressed it. A nice section view with a dimension, throw the dimension over here, we're good to go. They could have put the dimension right here actually, or off to the side down below. But this, just not the best way to do it. Give me another one. Yep.
I have a question about that one. What is
That one being, that one what?
the one we were just talking
The drawing or the question?
Yeah,
The drawing?
the actual dimensions,
Okay, yep.
using dimensions. Is there a blueprint we may come across that it will say it's, say, to scale, or give you the scale, and say the .375 was 1 inch. I mean, say they had that as written as 1 inch.
Yep.
So, therefore, if that was 1 inch, and we were going by scale, and the actual drawing was by scale, and that was 3 times this distance as that 1 inch,
Yep.
it would have to be 3 inches wide.
So I guess, if I understand it correctly, were we run into drawings where the scale and the actual dimensions conflict?
Or work together, incorporate.
Not really. No, not with modern day technology. The way that drawings are done, typically the scale will, I mean, physically, the drawing, they like the drawings and everything to work out. We don't really rely on scale anymore to get real measurements, okay? Why is that? Why do we not really want people putting their measuring tape down on a sheet of paper to measure something? Right, not realistic. And what are they likely to do? Make a mistake. So even though we put things to scale, that's sort of a caveat of reality. We're not actually going to want anybody to do that. Think of the reasons why. Everybody's sending digital blueprints back and forth. When it was originally created, it was created for maybe somebody's specific printer. Who knows if whoever printed it off for you hit a scaling factor that changed it just a hair and immediately threw off your scale. So we don't really rely on scales in the practical world that much at all because it's too much setup for error. So you're going on a set of plans, if you don't see a dimension, you send it back to the person who's responsible for giving you the dimensions. Don't try to measure it. There's just no reason for them not to have the dimensions on there, and you just run a risk by measuring by hand. Even on architectural drawings, now we'll do those somewhat, but we really don't encourage it. Another question. That's a good question too, because we're like, why do we even bother with scale being on there? It does get help a little bit. Sometimes you can confirm, but we don't want people building off of a blueprint to scale with their measuring tape. There's just too many things to go wrong. Give me another.
We're going to go over 20.
All right, 20. Okay, referring to the same drawing as previous question, noting that 2 dimensions identified as C. How could the designer simplify the drawing somewhat by combining this information into 1 dimension, explain or provide a dimension to accomplish this? Basically, sketch this out of your idea or describe it. So let's take a look at C.
So you just want to put times 2 or 2 times R 0, 500.
Yes, you could have just taken one of them and just said 2 by 2 X R, that's 0.5 in it, yeah, 0.5. That way the viewer would look at the drawing, and maybe you did it on this one, and they'll be able to visually tell that this is about the same size. They're going to know right off the bat that this is not the same size, so they're not going to confuse it, especially since it's got R1 here. So if I didn't show this radius, and I just put 2 by or 2x R 0.5 right here, that would be a way of getting rid of the problem. There's another way, and in this particular case they could have also done this. I'll just create it real fast. Here we go. Notch. All right. R 0.5 TYP. What do you think TYP stands for? Typical. Now, I'm going to be able to look at it when they still have this R1 down here and know we're not talking about it, right? So, what you'll see in drawings a lot of times is they'll use the typical or TYP and just omit everything else. So if I'm looking around and I see this radius and this one looks about the same size and there's no conflicting information, I'm going to assume that it too is R 0.5. So you could do it either way. You could actually call it out as a typical radius, or you could say 2 by R 0.5. Either one of those cases gets the job done. Now, one more, and then we gotta stop. This window of opportunity is closing, so give me a question. 23? Okay. All right, so 23. For the same drawing as previous question, aside from the fact that this is a rough sketch, would you say that section view AA is relatively correct feature-wise? So let's go take a look at 23. Or, I'm sorry, the section view. Okay, so we've got this section view. Again, a hand sketch. So we look at the part first off. We're cutting through this view, and we're looking to the left. Agreed? So let's see what we're going to be looking at. By the section view, it shows me that I'm looking at a surface beyond that my section plate doesn't cut right here. Agreed? Is that occurring over here? Yes. Now, should I have added in straight edges right here where these radiuses come to a stop? Or not? No. Remember, radiuses and surfaces that round off don't show up as edges. If it had been if I was looking this way, I'd have to see edges because there's a hard one right there. But this way, so that's not wrong. All right, so we look at the rest of it. Did I cut through a hole right here or anything to be showing up in the sidewalls? Nope. Okay, so we're good there. Does this feature that I'm cutting through go down and come across and go back up? Yeah, it does. And so then comes the real question. Is this part solid all the way the rest of the way down? There's the question. Well, let's look at the right side view. Well, actually, we can look at this view pretty easily and tell the part goes all the way down. So you can compare this section view with the front view and as if it happens here. And would you agree that this section view looks like it or not? Is there any tricks in there that I'm missing? That's correct. I mean, for the most part, it's a rough sketch, yes, but it is pretty much correct. There's no blatant obvious thing. Now, if I had thrown an extra little, hole or something, or if I had put a little notch down here, then we'd be talking a different story. But for the most part, that section is correct. Yep. Okay, I'll give you one more. Go ahead.
And if we look the other way, we would see that.
Absolutely. If we were, and we'll just do that just for the heck of it. So let's just say that we did a section view this way, like that. And so that section view, let me see if I can find some space here. Yes, it would look sort of like this. Hatching. And I wouldn't see anything over here where this thing transitions, but I see this right here. I would need to see a line right there, because you're looking at a hard surface change. You don't see this one because it's happening at the same edge right there, but you would see that right there. Does that make sense? Awesome. All right, so good stuff. And that kind of will let you handle the rest of it on your own, but that's kind of a good introduction to how these assignments work. They are thought-provoking. I do want to hear your answers. I do want to understand your answers. If it can be explained with a sketch, do a sketch. If you find a picture, do a picture. I'm really just wanting to see that you're thinking about this stuff, because a lot of the blueprint reading takes a lot of visualization and a lot of kind of a mental check going on. All right, so that's a good stop point there.